Bismillahirrahmanirrahim. In this video, I will discuss a fractional factorial design. We have a total of 8 parameters from A to H. The one response variable name is CONS, and there are two blocks that are represented by 1 and 2 in the first column. So I will make two videos. One only when there is no blocking effect, means I will not take care of this first column, and in the second video in which I will take this blocking effect. So after that I will write a report and I will discuss the whole thing from model adequacy, ANOVA, then model refinement, main effect plots, interaction effect plots, regression tables, and then now start. The first step is, as always, go to stat, then go to DOE, then go to factorial, create a factorial design. We have a 2-level factorial default generators, and the number of here is the 8. Click on it, then go to design. In the design, I have 1 by 16, only 16 runs. As you can see in the list I have, it's a resolution 4 design, and you can write it at 2 raised to power 8 minus 4. So in the first video I'm taking on the number of blocks 1, while in the next video I will take here number of blocks 2. Click OK, then go to the factors. So A, come down till from this down arrow button, and you can see our last parameter or variable name is H. Here the type, the low and high levels are represented by -1 and +1, similar to the data that have been provided to us. Then in next step we will click OK, then go to option. I strongly recommend you to please uncheck these randomized run. Click OK, and then nothing else to do. Click OK. So we got a design. In order to view only design, click here. Before going towards the data view, you can see it here, it's a resolution 4 design with fraction 1 by 16. There are total center point 0, and these are the default generators. So now only view. Now the next step is to enter a data for the response variable. So I will write here CONS, that is our response variable. You can enter a data similarly as you will enter in the Excel, just like 2, 3, 4. So let me enter a data. So the data has been entered. Now the data has been entered. The second step is analysis. So again, go to stat, then DOE, then factorial. Now click on analyze factorial design. Here you can click on it, then click on select. So response CONS has been selected. Nothing else to do except this thing, graphs. Here select 4 in 1, and then click OK, and then OK. After that, click here to view only the output. Slightly maximize your output by using this control and move it to almost 125. So when we move down first of all towards this, so we saw that we are unable to see any residual plots. Why? And further, in the ANOVA table we haven't got any F and P values. This is the main problem. Why? Because if you see, our error term has 0 degrees of freedom, and we are unable to calculate the means, sum of square, and then mean square. So the mean square is used in the computation of F value, and based upon our F value we compute P values. So now what's the solution? Now we have to do model refinement. Model refinement means that exclude or drop all those terms from the model that are insignificant or they have very low contribution. So how we can do it? There are two steps. One of them is graphically and the second one is numerically. So if we go for the numerical, then in this case you will have to divide these sum of square, this column SS, these sum of square. For example, the sum of square of A 0.13396 divided by total sum of square, that is equal to 1.69456, and then multiply the answer with the 100. You will get the percentage contributions. When you calculate the percentage contribution for all the main effects as well as 2-way interaction, so retain or keep only those terms that have a good percentage contribution, and drop all of them that haven't any good percentage. Now how we can do it visually? So go to stat, then go to DOE, then factorial, analyze factorial design. In the graph, click on half normal plot. So click OK, and then click OK. Again, output only, come down and focus on this half normal plot. So here the insignificant or not significant terms are represented by a blue circle. However, the significant terms, they are represented by the red squares. So we have to retain only those main effect terms first of all that are significant. They are A, B, C, D and then G. So we will have to memorize this, and then A, B and AC. So we will keep only these terms in our model. So for the third time, click on Stat, then DOE, then Factorial, Analyze Factorial Design, then go to the terms. In the term, move all these terms back by clicking this double arrow, and then move the term one by one. For example, A, then click on B, then click on click on C because these terms are significant, then D, and then we have G. After that, we have in the two-way interaction we have A, B significant, so move it, and then A, C. So this one is AC. So now we have to click OK. Nothing else in the graph. Click on no need of half normal, but it's needed these residual plots. So please must check this 4-in-1 option. Click OK and then OK. And then click on Air Output Only again. Come down to the graph of the residuals. Oh wow, they are somehow, it's a good data. This first graph and the third graph, it's telling that of data somehow following normal distribution. There are no significant outliers in the data. This second number graph, it's telling that the number of data points above this dashed line, that is the residuals at 0, it means that the positive residuals, number of positive residuals and the number of negative residuals below this dashed line, they are somehow equal in numbers. So that's why we can say the variance is constant. This fourth graph is telling that there is no cyclic pattern, crust and trough like this, no 6 or 7 points going upward or downward continuously. So there is no problem of the multicollinearity. So the assumptions are satisfied. We are now going towards the data analysis. So model summary is explaining that 99.67% variation in our response variable CO and S has been explained by these terms A, B, C, D, G and the two interaction A, B and AC. Now we come towards our ANOVA table. So in this ANOVA table, you can see all of the terms are found to be significant because their p-values are less than 0.05. Let me tell you one more thing, that in addition to this simple ANOVA graph, you can also generate by following these steps: Stat, DOE, Factorial, Analyze Factorial Design. In the results, go to the expanded table, click on it, then OK, and then here OK. So in this case, if you view only output, you can see these are the expanded tables and you will get the percentage contribution column. So that's most important thing. You can write in the report that the highest percentage contribution is for the variable G, followed by the interaction of AC, then the term B, like this. It will help you in writing the report in a very good way. Then we got this over mathematical model. What's the difference between mathematical model and the regression model? Because our data set was based upon coded units in the -1 and the +1. So this is a regression, this is the mathematical model. And if we have the actual values of our parameter instead of this -1 and +1 coded units, then we say it's a regression equation. So please remember this difference. Now the last thing is getting the graph. So go to again Stat, DOE, Factorial. So you can get here the plot, Factorial plots. Click here and then you have selected all of them. OK, then click OK, and the second option is keep only those that are significant. So you can see that with the increase in values of the parameter from their low level to high level, there is a positive increase in the response variable. Now it's time to get the two interaction graph that are found to be significant. So now go to Stat, ANOVA, interaction plot. In the interaction plot, select only those one of them was A and the second one was C, so click here OK. So we got our first interaction plot as the two lines are intersecting each other, so this graph is so it means that interaction is found to be significant. The second one we have significant is AB, so we will generate also for it. Go to again stat ANOVA interaction effect plot. Here select, instead of C, select this parameter in the column C6, that is variable B. So if we extend these two lines, they will definitely intersect with each other, so it means that there is a significant interaction between A and B. So now it's time to write the report. So first of all, model adequacy, then you will have to write a graph that figure 1 depicts the normality assumption has been satisfied, there are no outliers. It's same as I explained you. Pause the video, read it, and if you have any question, come back to me through email, through my WhatsApp. I'm always available at any time. However, there are few things that variance is constant. One of the graph is depicting. The second one is there is no correlation. This is the last graph is depicting, and no correlation means there is no problem of the multicollinearity. And after that, include the image of the ANOVA table in which we haven't any F and P values in the start. Then we have to do the model refinement. So write such a paragraph for the model refinement, and we have performed the model refinement using this half normal probability plot. Then include the revised ANOVA table in which we have percentage contributions. After that, perform the interpretation. So this report is basically for the blocking effect. I made it for my next video, in which I will explain this report step by step. However, if you want to explain, so the effect with respect to decreasing significance RE is the highest significant. You will write the degrees of freedom for the F, and 5 is the degree of freedom for the error. Then write this 652.65. This is the F value, comma P is equal to 0.000. Then the second one, this interaction term is found to be significant, so I write it on the second number as in the descending order. Likewise, write all of the results in the descending order. After that, under the heading of the mathematical model, include your model summary as well as the mathematical model. Then main effect plots under the heading of main effects. Then at the last there is an interaction effect plots, and then conclusion. In the conclusion, must write this to maximize the CONS or response variable. It is suggested to use A because I am working on the blocking. This report is regarding for that video. So you can see it here in the main effect plot. When we are going to increase the level of the A, or response variable decreasing. So this thing has been explained in the last line of the conclusion. Thanks for watching the video. Please watch the next video in which I have explained this report in a very better way, so that you can able to understand the fractional factorial design with blocking effect. Thanks for watching the video. Bye.